In this video, we will solve quadratic equations by factoring. I'm going to add one extra example, part F, 6x squared minus 3x equals 0. Okay, when we solve quadratic equations by factoring, we use something called the zero product property. The zero product property says if you have two things multiplied together, a product, set equal to 0, only one of those things needs to be 0. So for example, A could be 0, and it wouldn't matter what B was because 0 times anything is 0. Or B could be 0, and it wouldn't matter what A was because 0 times anything is 0. So when we solve quadratic equations by factoring, you always need 0 on one side of your equation. So looking at part A, we already have 0 on one side of the equation, so we factor the expression. We put x and x to multiply to x squared. I need two numbers that multiply to 48 and add to 19, which I believe would be 16 and 3 plus 16 plus 3. And now, to find the solutions, I need to figure out what numbers make each factor equal 0. So looking at this first factor, x plus 16, I want to figure out what number could I plug in for x that makes that factor equal 0, and that would be negative 16. Or I could make a little equation, x plus 16 equals 0, and subtract 16 from both sides, and we get x equals negative 16. But sometimes we can just do them in our head. In the next factor, I want to figure out what makes that factor 0, and that would be x equals negative 3. You can leave your answer like that, or you could write your answer in set notation with curly brackets. Either is fine. Ooh, that was not a very good curly bracket. But that's okay. Okay, so in the next one, this time we don't have 0 on one side. We can't use the zero product property if we don't have 0 on one side. So we need to get 0 on one side by moving the 126 over to the other side. And we're going to subtract it from both sides so it becomes minus 126 when it moves over. It changes sign. So we get y squared minus 15y minus 126 equals 0. And then feel free to pause and try to factor that yourself. And we get y, and we need two things that multiply to 126 and add to negative 15. I believe we want 21 and 6, and we want them to multiply to a negative, so they're going to have to be opposite signs, and then they need to add to negative 15y, so I want the bigger one to be negative, so minus 21 and plus 6. And then my answers, or my solutions, are the numbers that make each factor 0. So in the first factor, positive 21, and the second one, negative 6. And again, your answer could be left like this or in set notation. Okay. In the next one, we have two perfect squares, so we can factor the difference of squares. So we put m and m, 4 and 4, one's a plus, one's a minus. And our answers are going to be negative 4 and positive 4. And in the next one, we don't have 0 on one side. We could either move the 13x and the minus 45 over to the right side, or we could move negative 2x squared to the left side. I would recommend moving negative 2x squared over to the left side so that it becomes positive, because when we factor, it's much easier if our leading coefficient is positive. So I want the coefficient of x squared to be positive. So I move it over by adding it to both sides, and we get 2x squared plus 13x minus 45 equals 0. Now pause the video and factor that, please. I believe we want 2x and x to multiply to 2x squared. and then two numbers that multiply to 45. I'm going to guess 9 and 5, and I need to figure out where they should go. I'm going to put the 9 here and the 5 here, which gives me 5x and 18x. And if one of those is positive and the other negative, I want the 18x positive. That does add to 13x. So I put a minus here, a plus here. Okay, so now to figure out my solutions. When I look at 2x minus 5, I may not know right off the top of my head what number to put in for x to make that factor 0. So it's okay to write a little equation where you set it equal to 0. So we get 2x equals 5 and x equals 5 over 2. And then x equals negative 9 would be our other solution. Okay, in the next equation we have fractions, and that's no fun. So we're going to make our fractions go away by multiplying both sides of the equation by 2, which will cancel out the 2's in the denominators. But remember that all terms need to be multiplied by 2. Okay, so when I do 3 over 2h squared times 2, the 2's will just cancel out, leaving us with 3h squared. On the other side, when I multiply 2 by 11 over 2h, the 2's cancel, leaving me with 11h. And then minus 4 times 2 is minus 8. And I need to get 0 on one side. So I move I'm going to keep 3h squared where it is because it has a positive leading coefficient. And I'm going to move the other two terms to the other side, where they will change sign. So we get minus 11h plus 8 equals 0. Then I factor 3h and h, and maybe a 4 and a 2 or an 8 and a 1. I think 8 and 1 are going to work in this case. So I'm going to put an 8 here, a 1 here, both negative, and that gives me minus 8h minus 3h, which adds to negative 11h. Okay, so now that I've factored, I need to figure out what numbers make each factor equal to 0. So 3h minus 8 equals 0, 3h equals 8, h equals 8 over 3. And then h equals positive 1 would be the other solution. Okay, and in the last example, I just wanted to show a different type of factoring because we've learned lots of different factoring strategies. In this one, all we can do is factor out a GCF. So if we factor out 3x, we get 2x minus 1, distributive property backwards. And now I need to figure out what numbers make each factor 0. So if I look at 3x and figure out what makes that 0, you might be able to tell just by looking at it that the only number that makes that 0 is putting 0 in for x. Or you could make a little equation, 3x equals 0, x equals 0 over 3, which is just 0. Remember, a 0 on top is 0. So x equals 0 is one of our solutions. And the other, 2x minus 1 equals 0, 2x equals 1, x equals 1/2. And that is solving quadratic equations by factoring.